Okay, thank you. Thank you very much. Yeah, let's, because of time limitation, let's just quickly skip the, or maybe you can
No, let's skip the niceties and just get to it. Yeah.
Okay, thank you. Okay, probably let's start the panel. So the first of all, probably we can invite Professor Chang to explain what is alignment and what is the background, because unity alignment is very important for large language model, but what is the problem, how to define this problem, because that is very important. So let's first invite Professor Chang to give an introduction about this.
Thank you, Professor Chang. So alignment is probably the most, I think, important problem in AI that many engineers have never heard of. Or rather, they think of alignment and smush it together with a bunch of other problems like safety, control, etc. So the gloss of alignment is just how do we ensure that AI outputs align with our human values. I think we should distinguish two different ways alignment has been understood. There's the way the technologists understand alignment, and that goes all the way back to Norbert Weiner in the 1960s, where he said, we got to be careful. If we have a purpose for the machine, we want to design it for a certain goal, we better make sure that the goal we put into the machine aligns with our purposes, okay? Now, the way technologists understand alignment, I think, is deeply problematic in the following respect. And it really follows from Norbert Weiner's classical statement of the problem. Those of you who are creating startups or creating algorithms and so on, you might think that your goal vis-a-vis alignment is to make sure that the machine does what you want. So today's technologists, Stuart Russell at Berkeley, many of the other leading technologists will say the metric for alignment is match with our preferences. But that's the wrong metric for alignment because, and here's just a simple example to show why that is so, preferences aren't the right kind of thing for aligning with human values. Why is that? Well, Hitler has certain preferences, right? And you can clean his preferences up by making them logically consistent, removing his false non-evaluative beliefs and so on. And he might still prefer to get rid of certain classes of people. So we don't want machines to align with human preferences. They're not the right kind of thing. Or put another way, preferences can be the right metric for alignment only if they're scrubbed clean by values, human values, okay? And if that's true, then you might as well just go straight to values. Let's use values as the correct metric for alignment, right? Okay, so why is alignment important? Well, it's pretty obvious, right? I think of the simple case. Remember way back when Amazon created its hiring algorithm? Here's what Amazon had as its goal. Let's make the algorithm deliver the best candidate for the job. And what Amazon did was create an algorithm that did something else, namely found candidates whose CVs were the closest match to people that they've already hired on the books that they thought were successful. And of course, the result was that candidates who had women's chess champion on their CVs were downgraded. So alignment is extremely important. If we have AI that involves a kind of mismatch between the values we want our AI to achieve and what the AI actually does achieve, then the kind of future we have in a world full of AI is going to be disastrous.
Okay, so do you think there is some kind of like a fundamental, mistakes in the alignment here? And so, for example, because we know that you are working in Oxford University and you are thinking about a very long time for such kind of like alignment risks in AI. So do you think there is some kind of like mistakes or even in the alignment process?
Yeah. So I think that the way AI is being developed now, and not surprisingly by computer scientists and engineers, is fundamentally mistaken in two ways. And it's not surprising because, you know, engineers and computer scientists, when they hear the word values, they feel very uncomfortable. Like, what are those? And how are we supposed to get an algorithm to align with these mysterious things? And I can describe the two, what I think of as fundamental mistaken assumptions that current AI design, whether it's machine learning or symbolic systems, I think are guilty of. I mean, let me frame it like this. I think right now we're in a situation where there's a kind of fork in the road, right? There's some people who think, sure, our algorithms are not terribly well aligned with our human values, so let's just throw more compute, more reinforcement learning, human feedback, more fine tuning, let's do some more monitoring, let's scrub the data, and if we scale up, then the alignment problems will disappear. And I think some of what you said just now suggested that if we work harder and do more fine-tuning, roughly speaking, then alignment will follow. And as a philosopher who has studied values for, I won't say how long, but a long time, you know, there's an argument from axiology, which is the study of values, that says that isn't going to work. Right? So here are two fundamental assumptions that machine learning and symbolic systems currently make that, from a philosopher's point of view, involve serious mistakes about value. So the first one can be described quite simply by the King Midas story. And I know people here apparently are not familiar with that story, but King Midas, you know, he wants a bunch of stuff in his life, like a loving relationship with his daughter, health, happiness, peace in his kingdom, achievements, knowledge, etc. These are all values he wants in his life. And he assumes that the way to get it is by pursuing a non-evaluative proxy, namely gold. So the story is he wishes from the genie, look, you know, everything I touch, if it turns to gold, then I'm going to get all the goodies, the values that I want in my life. And of course, things are disastrous. He touches his daughter and she turns into gold and he can't have a loving relationship with her and so on. Okay, so that story, I think, is a perfect allegory for what's the first mistake that is built into AI design, machine learning and symbolic systems. And that is, they assume that if you want to achieve an evaluative end with an algorithm, right, you want to get the best person for your job, the way to get to the best thing, which is an evaluative end, is to pursue a non-evaluative proxy. Namely, you know, let's just get the CVs of the people that match the CVs of the people we already have on the books. And this is a fundamental error about how to achieve values. You can't achieve evaluative ends by pursuing non-evaluative proxies. And that is a guaranteed way to get misalignment between what a machine does and what humans value. So that's one mistake. The second mistake is, it has to do with the structure of value. And I know that sounds abstract and horribly philosophical, but let me just give you an example. When we humans make choices, often what we do is we, as it were, take out of our pocket a kind of balance scale. And we assume when you have an option between candidate A or candidate B to be the best candidate for the job, right? You put A on one side, B on the other, and then there are three possibilities. Scale goes up like that, goes down like that, or they're evenly balanced. And this corresponds to, excuse me, this corresponds to what I call trichotomy. That is the assumption that whenever you have to choose between two things in your life, one option has got to be better than the other, it has to be worse, or they have to be equally good. But this assumption, which is built into expected utility theory, economic approaches to decision making and so on, doesn't make room for hard choices. So if you have to choose between two really different careers, it's just not plausible that the only options are one career is better, it's worse, or they're equally good. Right, ski instructor versus lawyer, no, they're just qualitatively very different. Anyway, there's complicated arguments that I won't go into here, but the idea is that if you look at current algorithmic design, it's built into our algorithms that there are only 3 possible good outputs for a machine, right, in a choice between A and B. Choose A, choose B, or flip a coin. Those are the only good ways in which a machine can help us make decisions. But that leaves no room for hard choices where, as it were, the balance scale doesn't resolve, right? It's like that. And so since we humans face hard choices all the time, and we want our machines to align with our human values, the machines should face hard choices too.
Okay, thank you very much. So another question is that, so because you are talking about the alignment, the AI actually has 2 fundamental issues. So do you think that is simply because of currently AI is just data driven? So in the future, do you think that can we just add some kind of like a human valued function into the AI so that the AI can actually combine the like a human value and also data driven something, and so that the AI can itself align with the human, you could say, value.
Yeah. Okay, so if we put hard choices into our AI, if that output, this is a hard choice, can be something an AI can deliver as an output, then that allows us to put the human in the loop in a new way. Right? So whenever a machine faces a hard choice, candidate A, candidate B, it's hard, one is good in some ways, the other one's better in the other ways. The machine raises its hand, this is a hard choice, it kicks that choice back to the humans. So then the human hiring committee has to roll up its sleeves and start to look at the dossiers of A and B, and the humans have to do something which I think is distinctively human, which is commit to some feature of one of the candidates, like, oh, this candidate's a really good team player. And we in the firm, in the hiring committee, will now commit to being a good team player, add value to that wasn't there before through our commitment, and thereby resolve the hard choice. But notice that the human has to do the resolution. We can't outsource hard choices to machines. And once we put in hard choices as a possible good output for machines, then we ensure that humans are in the loop. Human judgment is always part of the human-machine interaction.
Okay. Yeah, so for the alignment of AI, actually there are quite a lot of future research and future development. So can you use 1 or 2 sentences to summarize the future direction in this research or something like that?
So the reason I got interested in AI is because I thought that the way AI is being developed now is, I'm really scared, okay? Because what's going to happen is, I mean, here's just a small way of thinking about why this is so frightening. If the human condition involves facing lots of hard choices, and if the machines that we are proliferating don't include the possibility of hard choices, then when we outsource our decision making to machines, which is, social science tells us, inevitable because we're lazy, and if a machine offers us a decision, we tend to go for it. We're going to end up with a world in which machines are taking what are, for us humans, hard choices and telling us that's better than that, when in fact that's not the case. So imagine, you know, you have some authority figure always telling you, look, you should be a ski instructor instead of a lawyer, even though that's a real hard choice for the rest of your life, right? That's the kind of AI future that I think we don't want. And the only way we can avoid that is by rethinking how we design AI.
Okay, thank you. Thank you very much. So probably it's time. So let's just thanks to Professor Chang for the comments about the alignment.
Thank you. I'm sorry.
Okay.
I forgot.
Yeah, thank you. So that's probably time for the next speaker. Okay, thank you.